Okay, okay. I'm audible, right? Okay, so hi everyone, how are you guys? I hope I'm audible loud and clear. Okay, perfect, perfect, guys. So in today's session, we are moving forward in the chapter circles, right? And in circles, today we are going to discuss, I would say, the most difficult thing. Okay, that would be way better, or I would say far away from your CBSE curriculum, right? We are going to discuss the alternative segment theorem. We're going to discuss how to write the equation of a circle. So far we have been learning about the circle, right? But actually, when you will be in your 11th grade, you will see that you have to find the equation of circle, and everything would be so much algebraical. Though you will be doing coordinate geometry, but you have to write the equations, and you have to write the equation of the tangent and other things. So we'll try to start that thing in today's session only. Okay. Apart from that, I'll also talk about a very important thing in terms of JEE mains and advanced as well. The number of tangent that we can have for two circles. What is the meaning of the direct common tangent? What is the transverse common tangent? These are some of the few things that we are going to discuss in today's session, right? So let's start then. Okay. Let me share my screen and then we're gonna start it. Just a second, guys. Okay, okay. Hold on, hold on, hold on. Okay, perfect. So I hope my screen is quite visible to everyone. And let's start the slideshow at the beginning. Okay, yeah. So look at this. As I told you that what are the topics of today? The topics are as given below. The first topic is your alternate segment theorem. Then common tangent. What is the meaning of them? We are going to discuss that part. Then we are going to discuss the equation of a circle as a locus, and then interaction. Nahi hai wo. It's intersection of two circles, right? So these are the four things we are going to talk about in today's session. Okay. The first thing. The first thing is called the alternate segment theorem, guys. Okay. So what is the meaning of the alternate segment theorem? This theorem says that you have a chord of a circle. Right now in the figure, the chord is given to you BC, right? Okay. Now this chord is making an angle with the tangent drawn at B. Okay. And according to the given diagram, the angle given to you is basically the angle over here is theta, right? Okay. Theta is the angle made by the chord with the tangent, right? Okay. And you can say there's one more angle that has been shown to in the figure, and that's alpha. Okay. That is the angle made by the chord BC in the other segment. Okay. That means the chord BC is over here. Oh, just a minute. I need to rub it, man. Oh, just a second, guys. Yeah. Okay. So now what I was saying is that if you look at the diagram, you can see one thing over here, that the chord BC is making an angle alpha, right? And that angle alpha is the angle made by the chord in the alternate segment. Okay. While theta is the angle made by the chord with the tangent over here, right? So what is the concept and what is the theorem? Theorem says that alternate angles will be equal to each other. That means alpha and theta, they will be equal to each other. First of all, we need to understand the theorem. What the theorem says, I'm repeating again my statement, that you have a circle. Okay. For that circle, you have a chord. That chord makes an angle with the tangent drawn at it. This is the angle, right? And now this chord make any angle in the alternate segment. So let's say this chord make an angle over here like that. The chord is what? BC. So what is the concept over here? That the angle BAC and the angle BCD, let's say, they are equal to each other. So if it is alpha, okay, it is alpha over in the figure. This is theta, right? So alpha and theta, these two angles will be equal to each other. That is the concept of alternate segment theorem. Okay. Now, first of all, we will see that, why it's true, why it's correct, how we prove this theorem. So look at this, guys. You have the circle over here. And for that, I have drawn a chord. And for the chord, I have drawn a tangent as well, right? Okay. Just a second. Thoda sa I need to draw it, on the other side. Then it will be more easier to understand. Just a second. Yeah. So the chord over here, the tangents drawn on the chord, right? And the center would be somewhere here, right, guys? Okay. Now look, if I'll join the point of contact with the center, I'll get this line. Okay. This is the center O. Fine. Okay. Now, what I'm doing is that I just name the points, first of all, A, B, C, and D. Okay. and I'll join this with this one and this one like that. Okay. So guys, the angle between the chord and this would be, let's say if it is ABCDE. Okay. So we need to prove that angle CAE. We need to prove this thing. Okay. Angle CAE would be equals to angle CDA. Angle CDA. This is something we need to prove. Okay. I'll write over here. Need to prove. Okay, and I did a bit construction. You can see that I have joined the point A with the center, and then I extended this line till B, right? And I have now I'll be joining that B with C as well, right? The B is the point on the circumference. Fine, guys. Now, first of all, let's try to talk about the triangle ABC. What you know about the triangle ABC? Let's see that part. Look, guys. In the triangle ABC, can I say first thing that angle BCA would be equals to 90 degree? How? Because this is the angle in the semicircle, right? We have been learning this thing from a long time that the angle in a semicircle is 90 degree. Okay, AB is the diameter, so angle BCA has to be 90. Now in this triangle, there are two angles remaining. The other two angles would be angle BAC plus angle ABC, right, guys? So can I say the sum of these two angles would also be 90 degree? Yeah, because sum of all the three is 180, right? Already one angle is 90, so sum of the other two has to be 90 degree. That's fine. Now, let's think about one very basic thing over here. That can I say that angle BAE is 90 degree as well? Huh. Why? Because over here, the angle, we have learned this, the first theorem of the chapter circle, right? The angle made by the tangent, the tangent with the radius is 90 degree, right? Okay, so angle between the radius and tangent, right? Radius and tangent, it's always 90 degree. Or I can say that if a line drawn from the center, it meets the tangent at 90 degree, right? Got it? Okay, that's fine. That's clear to us. Now, if this angle is 90, can I say that? Okay, that means you are saying that angle BAC plus angle CAE is 90, right? Because that's what BAE. Now, guys, just look at the equation number 1 and equation number 2, right? If I subtract these two equations, what I'll get? I'll get that angle ABC minus angle CAE would be 0, right? That means angle ABC and angle CAE, they are equal to each other. Now let's go back to diagram. I just proved that this angle and this angle, they are equal, right? This angle is alpha. This is also alpha, right? If you remember, we have learned one thing, and that is called the angle made by a chord in the same segment is equal, right? Or we have learned this in the 9th standard, basically. Angles in the same segment are equal, right? Okay. So by that, if I try to use this concept, what I'll say that angle CDA would be equals to angle ABC. Why? Because angles in the same segment. Angles in the same segment, right? Same segment. Now you just need to look at this one. That's what I got right now, and this one. So ABC and CAE is equal, and ABC and CDA is equal. That means CAE and CAE and CDA, they are also equal, right? So by using these two results, basically I can say that angle CAE would be equals to angle CD, and that's what we wanted to prove, right? That's what we have to prove, and we proved it, right? How we proved it? First of all, guys, we talked about the triangle ABC. In the triangle ABC, the angle BCA was 90 degree because it was the angle in the semicircle. And by that, we got that the sum of the other two angles will also be 90 degree. Then we said that, okay, angle BAE will also be 90. Now BAE can be written in two parts, BAC and CAE. Their sum has to be 90. Subtracted first and second, I got that ABC and CAE is equal. And then we already knew that CDA and ABC is also equal. Reasoning is very clear that the angles in the same segment are equal, right? So by comparing these two, we got the final thing, and that is that angle CAE and angle CDA are equal to each other, right? Or I can say that angles in the same segment are always equal to each other. Okay, I hope I'm pretty much clear to everyone. Is there any doubt? No doubt, right? Let's move forward. Perfect. So let's try to solve a few problems now based on it. The first problem is, guys, that in the given figure, angle CBD is 56 degree. So angle CBD is given to you. It's 56 degree over here. And angle ABC is 65 degree. ABC 65 degree. So can you find the angle ACB somehow? You have to find this angle. Can you find this angle, guys? Tell me. Tell me quickly. Take your time. Take your time and tell me the answers quickly. Any idea? Yes, actually, we have to use the previous theorem. That's what I told you. Absolutely correct. So look at this. By the theorem that we have learned, can I say that angle BAC would be equals to angle CBD? And that is given to 56 degree. Why? Because angle in the alternate segment, right? So I'll just write over here, alternate segment. So we have just learned that the angles in the alternate segment are equal, right? Okay. Now, array alternate segment ka matlab, this is not the meaning of alternate segment that you'll say that for a chord alternate segment angle are equal. No, 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 no. It's about the tangent. Tangent is drawn at B. The chord is BC. So angle between the tangent and the chord in one segment and the angle made by the chord on the circle in the other segment is equal. On the circumference, I would say rather. Okay. Now, by this, if I try to talk about triangle ABC, in triangle ABC, guys, angle BAC, okay, plus angle ABC plus angle ACB, right? Their sum has to be 180 degrees. Already, this is I have 56 degree. ABC we have 65 degrees, and then angle ACB, right? And that is 180 degree, right? So by that we got that ACB will be equals to 180 minus 121, right? And that would be equals to what? 59. So the answer is 59, right? Clear? Easy question. Got it? Let's move forward. Okay, perfect. So yeah, answer is correct. 59 is the correct answer. Yeah, we can move forward then. Next question, guys. In the given figure, XY is a tangent. Yeah, we can see that in the figure. To a circle at a point P, fine. With center O, great. PAB is 40 degree. PAB is 40. We have to find the angle, other two angles. Okay, fine. Guys, give it a try. Give it a try quickly. PAB is 40. We have to find APX by that somehow. And BPY as well. Look, so solve this question. What you do is that you join first of all this with the center right over here, right? Okay. Now in this figure, again, I'm going to use the alternate segment theorem. So I'm not writing much right now. I'm just putting it over here. This angle has to be 40 degree, right, guys? So basically, what I'm saying, what I'm trying to say over here is that angle BPY, right? Angle BPY would be same as angle PAB. Okay. Why? Because the alternate segment theorem. Okay. So now, okay, this is 40 degree. Fine. If it is 40, I know it is 50. How? Total is 90 now. By that, I can say that. Okay, fine. But now, here comes the important thing. Guys, isn't OA and OP are the radius, right? So angle in front of OA and angle in front of OP, they're going to be same, isn't it? If that is same, then can I say this angle has to be 40 again? And if this is 40, think about it. So 90 and this has to be 50 again, right? That means this also has to be 50. Alternate segment theorem again, right? So he asked me to find the angle APX. What is APX, by the way? It's 50. What is BPY? It's 40. So the answers are 50 and 40. I hope that's clear to everyone. How I got that? I need to explain again. Okay, fine. Look, first of all, what I did is that angle BPY 40 degree. So remaining would be 50 because the complete has to be 90. Okay. Wait a second. Wait a second. I'll explain it to you again, guys. Don't worry. Don't worry. Don't worry. I'll rub it first of all, and then I'll explain. Fine. By that you'll get more clarity. Yeah, that's why. Look at this. First of all, what I did in the question is that I have joined O with P. Okay. So look at this. I joined O with P. I use the alternate segment theorem. This is 40. This has to be 40, right? Now, angle OPY is 90 because the angle between the tangent and the radius, right? At the point of contact is 50. That means fine. Now, I know this is 90. Perpendicular, na? It's a like you can understand like that from okay, but you will be saying, sir, why it is 90? Okay, let's not make it 90 then. Let's not talk about that right now. In the triangle OAP, OA and OP are equal. That is so true, na? They are radius, right? So the isosceles triangle, that means this angle has to be what, 40 degree? Fine. That is true, na? Ab dekho. If this is 40, That means the like 40 is there in triangle APB. One is 90, one is 40. That means other has to be what, 50 degree. If this is 50, then by the alternate segment theorem, this has to be what again, 50. Okay, now it's clear to everyone. We got the answers. Clear now? Okay, let's move forward. Next thing. Next thing is the common tangent that, now what we are going to discuss about is that you have two circles. Okay. And in between these two circles, how many common tangents are possible? So actually that depends, distance between two centers. Basically that, either two circles, sorry, two circles are intersecting, or they are touching, or I would say intersecting, touching, they are like one circle in the other circle, like this kind of things, right? Okay, fine. Got it now? Okay, now look at this. I'll explain to you one by one all the cases first of all over here, and then I'll come back to that particular thing. First case is that one circle is like completely far away from the other circle. In that case, you can see, guys, we had four tangents, right? Tangent number one, tangent number two. Okay, common tangent I'm talking about. Common means the tangent which is a tangent of both circles, right? A line which is tangent of both the circle, right? One more would be like that. थोड़ा touch कर रहा है वो, ठीक है ना, थोड़ा सा वो. हाँ, wait. Okay, I'll make a good one. Actually ना, the problem is कि PPT के अंदर ना स्केल वगैरह यूज नहीं कर सकते, राइट? थोड़ा सा प्रॉपर बन जाता है वरना डायग्राम. नहीं यार, just a second guys. I will rub and I'll make a more other diagram यार. थोड़ा सा अच्छा बनाना पड़ेगा, I think. Right, वरना you will say कि सर समझ ही नहीं आ रहा. Just a second. A bigger circle, and then a tangent, so one more tangent like that, and one more tangent like that, right? No man, no. Arey yaar, come on, that's not possible. Arey, why I'm doing this? Wait. We have it now. Come on, diagram तो हमारे पास है ही already. I wasted a lot of time in that. Sorry. So guys, look at this. We already have a diagram here. We don't need to make it again, right? Look at this. So we have the circle C1 at the center at A, and the circle. You can, there are four tangents in between these circles, right? One is like outside tangent and one is like inside that one, right? There are four tangent possible. Four tangent over here, you can see. Okay. Now first, this is the first case actually we have to talk about. In this case, what is happening that the distance between the center of the circle is actually greater than the sum of their tangents. Look at this. Sum of the radius, sorry. This is R1 and this is R2, right? Okay. And distance between their circle is center is more than that, right? So for tangent case arrives, we reach to this case when the distance between the centers, that means C1, C2, is actually greater than the sum of the radius. If this thing is happening, in that case, we are going to get four tangent between two circles, right? So when we get the four tangent, first of all, when two circles are completely, apart from each other, okay. And when this case arrives, what is the mathematical condition for that? The mathematical condition is that C1, C2 would be more than R1 plus R2, right? Okay. Basically, that the sum of their radius has to be less than, the distance between their centers. Clear about that thing? Is there any doubt? Not about from that? Okay. Now, in that case, what is the important thing? That we get four tangent and we have name for those tangents, right? We call them DCT and TCT. Now that's important. We call them DCT and TCT. DCT is what? Direct common tangent. What is DCT? Direct common tangent. That is called DCT. And one more is called TCT. That is transverse common tangent. What we call it, guys? Transverse common tangent. But which one is transverse? Which one is direct? Very simple. Guys, direct means same side of the circle. Same side of both. And transverse means different side. Now you must be wondering, sir, what do you mean by that? Look at this. Look at this line over here, right? Can I say this line, the one which I have just marked, it is above both the circles, right? In fact, if I talk about this line, Can I say this is below the two circles? These two is basically the direct common tangent. This one is what? This is the direct common DCT, and it's also DCT, direct common tangent. Now there are two more remaining. Now look at this. Look at this one. I'm talking about this one, right? It is called TCT. Why? Look, because this tangent, if I talk about this one, guys, this one, okay, that one is for the first circle centered at A, right? For that it is below, or you can say it is to the right, okay. And for the circle centered at C, for that it is, above, or you can say it is in the left side, right? So for one it is in the left side, for one it is in the right side. That's why it is called TCT. Different side with respect to both the circles, right? This one is also TCT, and this one over here, this one. This is also what? TCT. So for this case, we have four tangent. Two are TCT, two are DCT. DCT is direct common tangent. TCT is transverse common tangent. In this case, we have four tangent, and when the four tangent case arrives, when two circles are apart from each other, or you can understand that C1, C2 is more than R1 plus R2. That's it. Got that part? Now, what comes over here is that how to find the length of these tangents, right? The formula for it, I'll tell you definitely. Length of DCT. That is equal to, guys, C1, C2 whole square minus R1 minus R2 whole square. What is C1, C2 over here? Distance between the centers of the circles. Distance between centers. R1 and R2, you know already, it's radius of the circles, right? What is the formula for length of TCT? Length of transverse common tangent, and that is equals to C1 C2 whole square minus R1 plus R2 whole square. Only one difference of plus and minus sign, right? And always the length of DCT is more than the length of TCT. You can see that in the DCT and the TCT, the difference is between R1 minus R2 and R1 plus R2 only, right? So in the DCT, whatever we are subtracting is a smaller number. In TCT, we are subtracting a larger number. When you subtract a larger number, you get a smaller value, right? Okay, that is the logic behind that the length of DCT is more than the length of TCT. Okay, fine. There was about the fourth case, four I would say a tangent case. There can be more cases. The second case I'm talking about right now is that when we have two tangents, you have one circle and you have other circle, they're touching, right? Look at this, guys. So one tangent is you have like that, other you have like that, and one more is like you have in between them is like that. Just a second. Yeah. So over here we have first of all three tangents. Now when the three tangent case is arriving, look at this, pay attention, this is important. Look at this. The distance between their center is same as the sum of the radius, right? When I'm writing C1, C2, na, C1, C2 matlab distance between their centers, right? So over here in the figure, you can see that the distance between the center is same as the sum of the radius, right? Because look at this now. This is C1, this is C2. And from here to here it is R1. And from here to here it is R2. So C1, C2 is same as R1 plus R2, right? So we have three tangents in that case. Out of these three tangents, you can see over here that two tangents are what? DCT, and one is what? TCT, right, everyone? And for the length, you can use the formulas that I already told you. That's about the second case. Third case. Third case में क्या हो सकता है when the circle is intersecting like that. Okay. In that case, you will have only two tangents. Okay. Now, when this case will be arriving to us, let's see that thing. First of all, we have two tangents and both of them are DCT. Now this case arrive, look at this, guys. The distance between their center is actually more than, less than the sum of their radius, right? So C1, C2 is actually lesser than sum of their radius, but it has to be more than the difference of their radius in a mod. Okay, why I'm talking about the difference of their radius, by the way, over here. Yeah, one thing we can see over here that yeah, C1, C2 is definitely less than R1 plus R2 because R1 is from here to here, R2 is from here to here. So C1 and C2 can, there is some part which is not coming over here, right? Definitely this is true that C1, C2 has to be over here more than sorry, yeah, less than R1 plus R2, right? But what about that? Why it is has to be more than from that particular thing, right? So let's understand that part now. Just a second. अरे यार, circle रब होगा क्या? चलो कोई नहीं. I'll draw it again. Just a sec, guys. So okay. Okay, it's like that. थोड़ा सा बेकार हो गया, but ठीक है. अब देखो, why I'm saying about this case, I'll explain to you that thing. Look at this. What is happening in this case? Actually, C1, C2 is exactly equal to R1 minus R2. So when you wrote now that C1 C2 is basically less than R1 plus R2, this case can also be possible. Now what if it is equal to R1 minus R2? Then the third case will not be possible. Then this case will be coming, and in that case only we have one common tangent, right? So in this case we have only one common tangent. Okay, fine. Got it, guys? Okay. Is there any case in which we can get no zero tangent? Yeah. When one circle is completely inside the other circle, you will get no tangents, right? Okay. So let me just tell you about that now. So we have discussed these cases: 4 tangent, 3 tangent, 2 tangent, 1 tangent, and no tangent. And these are the conditions that also I have discussed, right? अच्छा यहाँ पे एक डाउट था, किसने पूछा भी था, सर व्हाट इज दिस R1 माइनस R2 mod and why we are putting into the R1 minus R2? बहुत सिंपल कॉन्सेप्ट है. देखो, C1 C2 is the distance between their centers, right? Now we know that C1 C2 is always a positive number. Huh? Because it is distance between 2 points. Now distance between 2 points is always more than 0. Positive number, right? So over here what is happening, that when I'm writing R1 minus R2, I don't know which one is more, right? Maybe R2 is more, maybe R1 is more, right? Depends now. I'm not sure which one is more. Maybe R1 can be more and maybe R2 can be more, right? We are not sure about that, which one would be more, right? So that's why we are like putting a mod. Thus we can make it positive. Let's say अगर देखो मैं example देता हूँ, R1 2 है और R2 5 है. 2 minus 3 will be minus 2 minus 5 will be minus 3. Now you are saying that C1 C2 is equal to R1 minus R2. Distance between center is equal to minus 3. What kind of statement it is? Distance is minus 3. That's not possible, man. It's distance, it's not displacement, it's distance. It has to be always positive, right? Okay, so distance has to be always positive. That's why what we'll do is that we'll keep a mod. Mod अगर नहीं आप लोगों को पता है तो you can understand mod is like the positive value of something. Minus mod of minus 5 is 5. Okay, mod of minus 10 is 10. Mod of minus 100 is 100, right? So you have to take the positive of this thing. Got it? Let's move forward now. So let's read it. What are the important facts? When one circle lies completely inside the other circle, then there is no common tangent. Absolutely correct. This case I'm talking about. Fine. When two circles touch each other internally, one common tangent can be drawn. Yeah. Fourth part. When two circles intersect in two real and different points, two tangents. Yeah. The part number 3. Okay. When two circles touch each other externally, part number 2, guys. Look at this. They are touching each other externally, and we have 3 tangents, right? The last one says that when two circles neither touch nor intersect and one lies outside the other, 4 tangents. Yeah. Part number 1, the circle, they are not touching, they are not cutting, and they are not lying inside. In fact, they are like completely outside of each other. In that case, we get 4 tangents, right? Got that part now, everyone? Question solve करते हैं, चलो. Try करो एक बार question को फटाफट से. Try this question, everyone. I'm giving you 2 minutes for this. Come on, fast. It's a good question. Give it a try. Waiting for the answers. Take your time. बता देता हूँ, ठीक है ना? अब देखो, there are two circuit touch each other externally. Great. Radius of first is 8, second is 4. Find the length of their common tangent to BC. Okay. Radius of first circle is 8. यार देखो, यहाँ पर निकालनी है आपको कॉमन टेंजेंट की, BC की, और वो क्या है आपकी DCT है. So I just told the formula for DCT, right? What is the formula for DCT? It was C1 C2 whole square minus R1 minus R2 whole square, right? अब ये टच कर रहे हैं दो सर्कल्स, so what is OA? OA is C1 C2. C1 C2 is OA, and that is 8 plus 4, and that's 12. Okay, so C1 C2 is 12. R1 R2 you already have, so you'll just write that 12 square minus R1 minus R2. That means 8 minus 4 whole square, right? So 12 ka square 144, 4 ka square 16. So 128, right? Okay, guys. And that would be 2 power 5. So that means 8 root 2. That's your answer, right? That's it. 8 root 2 is correct answer. Got it? You just need to use the formula. That's it. Yeah, BC is DCT. Now we have to find BC, and that is direct common tangent, right? If we need to find the transverse common tangent, we'll use the plus sign. So we'll write C1 C2 whole square minus R1 plus R2 whole square. That's the only difference. Okay. Got that part? Clear hai sabko? Okay, let's move forward then. Now here comes the most important thing about the locus and the equation of a circle, right? So I'll just come back to this part again. First of all, let me explain this to you over here. देखो अभी अगर if you remember guys, we did one chapter that's called coordinate geometry, right? In that we have learned the distance formula, okay? So we are going to use that only. Now just pay attention on this thing. What is the meaning of a circle, by the way? Look, a circle is, we have already discussed this part, that a point is moving in a way such that the distance of this point from a fixed point always remains a constant, right? Okay, I have given the example that, I am moving, there's a pole in my hand and I'm moving around it. I'm covering a particular path, and when I'm covering this particular path, I'm making a circle, right? Okay, so let's say the pole is somewhere here and I'm moving over here, right? Let's say this point, this is point P. Now in mathematical, in maths, you always know this thing that, a fixed point or a fixed thing we can take like x1, y1, right? And the variable thing, how we take the variable thing, by the way? We take the variable thing as xy. Okay. Now I know one thing, that the distance between OP is always equal to the radius of the circle, right? Okay. I know that OP would be equals to R, the radius of the circle, right? What is O over here? O is the center of the circle. So I'll write over here, O is what? O is the center. And whose coordinate is what? It is x1, y1. And P is any point, any variable point on the circle, right? Because whatever, like P can be over here as well. P can be over here as well. In all the cases, wherever you are taking the point P, the distance between OP will always be equals to R, right? The distance between OP will be always be equal to the radius of the circle, I would say, in that sense, right? Now, what is OP, by the way? Can I have a distance from how to get that? Yep, we can. So I'll get x minus x1 whole square plus y minus y1 whole square, right? I hope everyone remember distance formula, guys. And inside a square root, and that is equals to R. If you do the square both sides, do square both sides, what you get? You get x minus x1 whole square plus y minus y1 whole square equal to R square. Now, as I said that here x and y can be any point lying on the circumference, right? That means this equation, I wrote an equation over here. You can see it's an equation, right? It's an equation in terms of x and y, where the power of x can be 2 and power of y can also be 2, right? So this is an equation in terms of x and y. And this equation is representing all the points lying on the circumference of the circle, right? Because P can be any point on the circumference, right? So this thing is called this is called the equation of the circle, right? Why it is called the equation of circle? Because it is representing all the points lying on its circumference, right? This is the equation of a circle. Now, what we know about it, by the way, we know one thing, that if the equation of circle is x minus x1 whole square plus y minus y1 whole square equal to R square, then x1, y1 is known as its center and R is basically the radius over here, right? Okay, so what is the circle? Circle is basically a movement of a point which moves such that the distance of this point, the moving point P from the fixed point O, is always remains a constant, and that constant is the radii of the circle, the radius of the circle, right, everyone? Let's go back, let's come back and let's see what we have wrote earlier. We wrote that in algebraic term, a circle is set of the point at some fixed distance R from the fixed point h comma k. The value of R is radius and h comma k is called the center. Yeah, that's fine. If you want that the center is h comma k, right? If you are saying no, for me the center is not x1 y1, it is h comma k, then what's the problem? At the place of x1 I can put h, right? Okay, at the place of y1 I can put k, doesn't matter. This kind of equation would become x minus h whole square plus y minus k whole square equals to R square, if you are saying that center is x1 y1, right? That's what you wrote. You wrote the equation as x minus h whole square plus y minus k whole square equals to R square, because you are considering the center to be h comma k. Okay. Second thing, you said that, okay, what if the circle is centered at the origin? Arey, simple hai na baba. Agar circle is centered at the origin, then h would be 0, right? K will also be 0. So what you get? You get x minus 0 ka whole square plus y minus 0 ka whole square equals to r square, right? Or you can understand it like that. X square plus y square equal to r square directly. Because h 0 है ना, क्या फर्क पड़ता है 0 से? हमका 0 से का ही फर्क नहीं पड़ता, कोई फर्क नहीं पड़ता हमको 0 से, ठीक है? नहीं पड़ता ना? Got that point, everyone? Should I move forward then? I should move forward, right? Okay, perfect. So we have understood the equation of circle, everyone. Look at this question now. State the center radii of the circle and sketch the circle. ये बहुत सिंपल है, देखो अभी आप लोगों को बोला कि x minus x1 whole square plus, देखो मैंने अभी आप लोगों को बोला, what I just told you guys is that this is the equation of the circle, right? Just compare these two basically. Over here x1 is 2, y1 is 0, and r square is 5 square, so r square is 5 square, right? What is the center? That means 2 comma 0 is the center, right? X1 y1 is the center. We have already discussed that part. And what is the radius of the circle? The radius is what? It is 5. So a circle you have to draw which is centered at 2 comma 0 over here, and the radius is 5, so that means circle is like that, right? So ऊपर ये आएगा नहीं, but ऐसा आएगा circle, ठीक है ना? Wait a second guys, I will draw it somewhere else because here it's not very much visible. Just a second. Just a second. Okay, look at this. I'll show it over here. So देखो ये आपको दिख रहा है, ग्राफ भी है, so you will be understanding more effectively over here. Look at this. This is a point 2 comma 0, right? You can see that center is 2 comma 0. What is this point, by the way? Radius is what? 5. तो 2 से 5 जाओगे left में, so what you'll get? You'll get minus 3 comma 0. And this is like 7 comma 0, right? You can see this thing, right? Look at this. Distance between these two is 5. Distance over here is also 5, right? Okay. So you can get this endpoint of the diameter as well over here. Got it? Is there any doubt? Let's move forward then. Okay. Intersection of two circles. अब देखो यार, इसमें ना एक important बात है कि what is the meaning of intersection of two circles and how actually they intersect. So if I'm talking about the intersection of two circles, now they can intersect in 3 ways actually. Okay. Basically, if two circles are intersecting like that, or maybe like that, or maybe like that. So when two circles are apart from each other, right, they have no point of intersection. There is no real point where they are intersecting. Okay. When they are touching, they have one single point. Okay. And when they are like intersecting each other completely, then we have two different points. Okay. And in fact, what I discussed you already is that in this case, you'll get 2 tangent, the common tangent. Here you get 3 common tangent, right? Okay, and here you got 4 common tangents. I already discussed about you, right, guys? Okay, but yeah, right now we're coming to that point that two circles may intersect at two imaginary points. That means the point are not existing even, and a single point where they can intersect, and they can also intersect, or two different points, right? Two distinct points they can intersect, right? Okay. If they are intersecting, guys, on two different points, so if I join these 2 points, I'll get a line. Okay. If I'm talking about the first case where there are two circles and they are intersecting at one particular point, so two particular points, if I join these 2 particular points, I get a line. Okay. This line is called the radical line. So what is this? The second statement saying is that the intersection of two circles is called the radical line. Okay. Now, अब देखो बात यहाँ पे ये है कि if I'll give you equation of two circle and I am saying that there is one more circle that passes through the intersection of these two circles. क्या बोल दिया सर आपने? ये देखो, ये circle 1, circle 2, they are intersecting at 2 points. Now I am saying that you need to find the equation of other circle, circle number 3, which passes through the intersection of these two circles. एक circle find out करो जो pass करेगा A से और B से. How you gonna find that? Very simple. You write the equation of first circle, you write the equation of second circle, and then use a constant in between them. Okay, so I'll just explain you by an example that would be more good. Look at this. Find the equation of a circle through the intersection of these two circles, right? So what I said is that we need to find the equation of a circle, guys, that passes through the intersection of two given circles, right? Over here. What I'll do, I'll write the equation of the first circle first of all. X square plus y square minus x plus 7y minus 3 plus some constant k times. I'll write the equation of the other circle, and that would be x square plus y square minus 5x minus y plus 1 equal to 0. Okay, fine. If I compare, if I solve, what I'm going to get? I'm going to get 1 plus k times x square. Okay, plus 1 plus k times y square, and okay, so plus -1 minus 5k times x, okay guys, and then plus 7 minus k times y, okay, and then plus k minus 3 has to be 0. Abhi, he is saying that center lies on the line x plus y equal to 0, right? But what is the center over here? अभी मैं बता रहा हूँ, but I'll explain how it comes. Don't worry about that, okay? Center is basically over here, which will become 5k plus 1 over 1 plus k, comma k minus 7 over 1 plus k. And it lies on the line x plus y equal to 0, right? So basically x equals to minus of y. Okay, so if you solve this, you'll get that 5k plus 1 divided by k plus 1 would be negative of k minus 7 over k plus 1. From there, you will find the value of k, right? Why I'm saying x equals to minus y? Because it is given to me, right? Look at this. The center lies on the line x plus y equal to 0. I can write x plus y equal to 0 as x equals to minus y. Center is lying on the line, right? So basically, if center lies on the line x plus y equal to 0, if x is basically, I can say that, okay, x and y, they are equal in their values, but they are different in their signs, right? Because x is coming as minus of y. Okay, so what I did is I did the same thing. X kya tha? X was 5k plus 1 over k plus 1. And what was the y? Y was k minus 1, k minus 7 over k plus 1. So I did x equals to minus of y. Solve it, you get the value of k. K aata hai yahan se 1. You solve it, you get the value of k is 1. That's it. So if you'll just substitute k equals to 1 over here again, you get the answer, right? So what you will have to do after this step is that in the last one, if substitute just k equals to 1, you get the final answer. Look at this. Over here, I'm talking about actually. Oh, just a sec. So just here you put k equals to 1, because after solving this, you are going to get k equals to 1, right? Okay. But a big important point here is, sir, everything is fine, but from where you got the center, that's important point. We need to discuss that, right? So look at this. I'll explain to you over here. Okay. I'm explaining this part over here, guys. Okay. Not here. I'll explain it over here, right? Look at this. If you have the equation of a circle is, let's say, ax square plus by square, I'll write for now, plus अभी मैं तो दो चीज है, मैं आपको 2g बताऊं या ना बताऊं. ओके, वेट अ सेकंड गाइस. एक्चुअली यहाँ पे ना 2 से डिवाइड भी करना पड़ेगा इसको. सेंटर ना एक्चुअली में ये होता है, डिवाइड नहीं किया मैंने, यहाँ पे 2 से डिवाइड भी करना पड़ेगा. Though the answer is going to be same because both side 2 will be there, so it will get cancelled out. But we need to know it actually, है ना. डिवाइड बाय 2 भी करते हैं. क्यों करते हैं समझाता हूँ आप लोगों को. Okay, let's say the equation of circle is ax square plus by square plus cx plus dy plus some constant z equal to 0, right? So center होता है ना, center क्या होता है basically, वो होता है minus of c by 2a comma minus of d by 2a. That's the center. Okay, basically coefficient of x को negative करके divided by 2 कर दो, or you can understand like that, coefficient of x minus times coefficient of x divided by 2 times coefficient of x square minus times coefficient of y divided by 2 times coefficient of x square. Okay. One important thing over here is that I can write like ऐसा होगा इसके अंदर हमेशा सर्कल के अंदर ना x square y square हमेशा सेम ही रहेंगे coefficient. Don't worry about that. Don't bother. You don't need to bother much about that, right? Okay, it will always remain the same. So look at this. In this question, you got the equation as this now. You get this part you got, right? Okay. So the x square coefficient is 1 plus lambda, y square guy 1 plus lambda, right? So a is actually 1 plus lambda over here. I'll explain by this now. A is coefficient of x square, y square, it's 1 plus lambda. What is the coefficient of x? That is c. That's for us is minus 1 plus 5 lambda, okay? And what is the d? Coefficient of y. And that is what? Coefficient of y is 7 minus lambda, right? What is my answer? My answer is that center has to be minus of c by 2a. So minus of minus. So 1 minus 1 will become plus. So plus times of 1 plus 5 lambda divided by 2 times of a. 2 times of 1 plus lambda. And what is the d? With a negative sign. So d is 7 minus lambda. Minus d would be lambda minus 7, right? And 2 times of a. What is a? It's 1 plus lambda, right? So what is that? Center is getting at 1 over 1 plus 5 lambda over 2 times 1 plus lambda and lambda minus 7 over 2 times 1 plus lambda, right? And that's how you get the center. Once you have the center, you have to put the center on the line x plus y equals to 1, 0, and from there you get the lambda value. Lambda को वापस से put करके you will get the point of you get the equation of a circle, right? ये important point है. You need to remember this. Fine. Okay, everyone got it? So basically, in the equation of circle, we learned two major things. Equation of circle, how to find this part. And then also we have learned about this part, right? That if the equation is given to you, then how to find the center, okay? We also told you about that. So basically, I discussed two things. First thing is that if the equation of a circle is given to you, how to find the center. And if center is given to you, how to find the equation. Both the things I have discussed, right? Okay, everyone? So I hope I'm pretty much clear today. Homework questions are there. Just note down the homework question, then I'll end the class. Question number 1, 2, and 3. I'm giving you 2 minutes. Note it down. And then that's it from my end. The next thing we'll discuss in the next class. Okay, guys? Fine enough? See you then. Yeah, absolutely, absolutely. Whatever doubts you have the PDF to post the doubts, right? And I'm always available, as I said. Okay. Okay, bye bye. Take care. Have a nice day ahead. Yeah, note down these questions. Okay.